So the next task is reverse linked list. We are given head of singly linked list and two integers left and right, where left is less or equal to right. We need to reverse the nodes of the list from position left to position right and return the reverse list. This question is asked by Amazon, Google, Microsoft, Bloomberg, Apple, etc. So first of all, we need to check that head exists. If not head, we just return head. And after that, we need to find the first node before the reverse and the starting node from which we start reversing. So for that, I'm going to use just current and pref. Pref is going to be the this one, so before the reverse, so it can be none. And then while we will subtract left and right to record to check if we are in the position where we can start reversing. So while left is greater than 1, we just move current. First of all, we need to record current as a pref, and then just current is next. We need to subtract left from left and also subtract from right. So let's say left is initially 2 here, and current is here. Is left greater than 1? Yes, we move 1 point here. So current is here right now, and previous is here. So we know where we start, so let's just record it on a separate variable. I'm calling it before reverse. So before reverse is previous, 1 in our case. And I also need to record the start of the reverse. I'll record it as a start. So it is going to be a current element. And now while we reach the end of the reverse, we need to check right while it is greater than 0, because we need to get out of this reversing element. So for instance, right is 4 here. After one iteration, it becomes 3. So current is here. Current moves 1. Right becomes 2. Current moves also 1 time. Right becomes 1. And then current moves also 1 time. Current becomes 0. So at this point, our current is the node after the reverse. So that's why it's 0 here. Okay, and now we need to record the next element of the current. And then we should change this arrow back to previous element. The current up next is ahead, or is a previous one. Previous is going to be a current element, and current is going to be a next element. So what we've done here, let's say previous is 2, current is 3. We move this arrow back to 2. And then we move to the 4, current element, previous element moves to 3, current element moves to 4. We change the arrow from here to there, from 5 to 3. So basically, we reverse the list, and then our current element points to the after reverse, and then end should be 4, so end is going to be a previous one. So great, yeah. And now what we need to do is we need to point this one to 4, not to 2. So for that, we know that 4 is end of the reverse, so before reverse. But next is going to be a previous one, which is 4. And also we need to point this one to 5. And we previously recorded as start. So start.next is going to be after reverse. And then we just return the head. And interestingly, the before reverse can also be none, because we might receive like left is 0, left is 1. So in this case, before reverse is none. So we need to check it here. If before reverse is not none, we set it's next. But if it is none, in that case, our head is now the element, the end of the reversing element, so head is proof. So let's say that we don't have this one here. In that case, before reverse is not initialized. So in that case, 4 should be ahead. Let's try to run our code. So I forgot to subtract 1 from right. So yeah, our code is accepted. Let's submit. That's the end of the tutorial, and let's do some complexity analysis. Time complexity of this algorithm is going to be O of n. It is linear, and interestingly, n is not the length of the. Yeah, we can assume it as in the worst case, it is size of the list, but it's going to be, I think, correct if we will say that. Yeah, let's say keep it as a linear, and space complexity is just constant time because we are not using any extra space.